Okay, so I'm calling this Simplifying Complex Fractions Part 2. We did Part 1 a while ago, and I'll remind you of what that is in just a second. So today we're going to take what we learned a couple weeks ago, and we're going to build on that a little bit. So first of all, let me remind you about what Part 1 was. Really good, nice job. So here's an example of one. 2 over a is equal to 4 over a squared, right? Remember that fun thing? Sure. So Henry's going to tell me what to do to handle this situation. What do we do, Henry?
So just put equal sign, or okay, just put next to it, put 2 over a divided by.
Oh, okay, got you.
You rewrite it. Over a divided by. What's the bottom? I can't see.
4 over a squared.
A squared.
Okay.
And then what you got to do is you got to flip it so that equals 2 over a multiplied by a squared over 4, and then you can cross cancel. Just cross out the 2, and then cross out the 4, make it a 2, so and then cross out the a, and cross out the a squared, and then it becomes a over 2.
Henry, you deserve like multiple points for that. I'm going to give you a couple points.
All right, thank you.
I'm in the wrong class.
I feel like nobody's feeling good today.
Yeah, we should have I'm feeling great.
I'm doing all right. All right. So check your steps, right? So first, step one was to rewrite it as a division problem. Okay, guys, quiet, please. Nathaniel? All right. Yep, use the steps. And then after we change to a division problem, we do keep, change, flip. And then we reduce. And then we're done. So that's the process we went through. That was part 1. Now we're gonna build on that a little bit today, using what we've been learning through the past couple of classes. But it won't be. We're gonna be adding fractions again today, but it's not going to be as hard as the past 2 classes. It'll be a little bit easier. So let's well, not the past 2 classes. Past 2 classes have been rough. You've been doing good, but it has been hard for many. So well, we'll see. All together, I don't know, but the type of adding we're going to do is a little bit different. So let's. Yes, I am. Let's do another type of review. Ready? What if I gave you guys 5 over x squared plus 3 over x, and I asked you to add these together. So we need to review this too really quick.
Is that a new writing software?
It is. This is actually my original writing software, which they finally got reinstalled yesterday. So now I'm back to where I was, and I'm very happy.
From the other one?
Yeah. All right. So I think I meant to put a 2 here. Let's throw a 2, just to kind of spice things up a little bit. All right. So whenever you want to add 2 fractions together, what do you have to have? So I want you, while I get the phone, I want you guys to think about what do you need to multiply each side by to get them to match, and I'll be right with you. Kiara?
Who?
That's what she said. Kiara, sorry. All right. So, what do I multiply this side by?
2.
And what do I multiply this side by?
X top and bottom.
Good job. And then if those 2 reviews were easy for you, then you have one final hurdle to get through today, and that's putting those 2 things together. But let's go ahead and finish the problem here. So the top here is now going to be 10 over 2x squared, right? Plus 3x over 2x squared. And now that they have a common denominator, we can go ahead and put the tops together, right? Now, can I combine those, or are they not like terms? They're not like terms. So what we do is we just put them together, but without combining the numbers over the common denominator there. Okay? So that's if you could do the two things that we just did, then today's lesson should just be a matter of putting those ideas together into one problem.
Wait. Of the other one now.
Yeah, so I'll show you an example, yeah. All right.
This is today's lesson?
Yeah. Well, it's the components of today's lesson. So now that we've got that, we're going to go ahead and actually transition here into an actual problem. Here we go. So go ahead and write down example 1 here for me. Actually, let me do something real quick. All right. And I want this to be slightly bigger for you so you can see better.
Oh, that looks amazing.
There you go.
What's that thing?
That's my notes. You can ignore it. It means teacher example, guided practice, student practice, but you can ignore it. It's kind of irrelevant.
Ooh, organized.
I
So
tried.
this is example 1.
This is example 1. Yeah, thank you for asking. Example 1. Okay, so here's what we're going to do.
Purple.
We're going to take the two ideas that we just talked about and put them together into one problem. So the first thing that we're going to do is we're going to combine the two fractions together. So in the numerator. Sometimes they'll be in the denominator. But do you guys see how there's two fractions here in the top? Now, before when we had complex fractions, we had one fraction in the top, one fraction in the bottom, and that was it. But now I've got a fraction and a fraction in the top. So how we're going to deal with that is we're going to combine those together first. So the first thing we're going to do is combine the two fractions. Can't see the color?
I like that color. It's my favorite color.
I like the purple.
I'm going to put numerator, but I want you guys to understand it's not always in the numerator, okay? You could have the two fractions in the bottom that need to be combined, right? So anytime you have two fractions being added or subtracted, we're actually going to add or subtract them. So let's go ahead and do this. So if I want to combine these two fractions in the top, what would I need to multiply this side by?
4.
And what would I need to multiply this one by? Good. And I'm going to put this binomial in parentheses there because we want to know that we're distributing it into the whole thing, right? So let's go ahead and rewrite that now. So we have, what's the first fraction going to be now?
16 over 4x squared.
Good.
And then minus x squared parentheses x minus 2.
I think we can actually go ahead and put them together. Let's distribute.
X to the third minus 2x squared.
Cool. All right. So there's that. And the bottom, we're not doing anything with that, right? That's just staying the same. We're still not quite done with step 1 yet because all we've done is gotten a common denominator, but that's so we can do step 1. We haven't done it yet. Now we're going to actually go ahead and combine them. So
Distribute the negative first.
you're right. Very good. I want to combine these, right? And before I do, we want to remember to distribute your negative here. So that's going to become the following. 16 minus x cubed and what? Plus 2x squared.
Do we write that in that order, or can we write it in receding?
Either way. So all I've done is I've combined the two fractions in the numerator so far. That's all I've done.
So that's not our answer.
That's not our final answer. So now it's like the very first problem we had today at the beginning, where you have a complex fraction, so you change it to a division problem, and then you do same change flip. So that's basically the strategy for today. Combine the two fractions together that are in the top, or the two fractions that are together in the bottom, then solve the complex fraction. So when you're doing complex fraction, the next thing you're going to do is you're going to change it to a division problem. So how would I write this as a division problem? I'm going to have to change screens here. You guys good with that?
I mean, I feel like before you do all that, you should first solve the top fraction with the 16.
Okay.
Like, I feel like you should split it up. Oh wait, hold up, that's gonna be a pain. Wait.
Well, there's nothing we
Henry, we're
can
done with
do.
the top.
The top is done. Like, you can't factor this,
I know, I just noticed that right now.
and so we can't reduce it. So that one's done. It's ugly, but it's done. So we have 16. How am I going to write this as a division problem? So it's 16 minus x cubed plus 2x squared, right?
Over 4x squared.
Over 4x squared divided by what?
X. Over
X. Good. So it's divided by x. And yeah, we'll get to the over 1 part. So I'll come back to this, but what we do is we do this, the top fraction divided by the bottom, right?
So it becomes x over 1 because it's not a denominator.
Yeah, you're right. And we talked about that back then too. I'm going to say what John's saying in case you didn't hear him. When this is not a fraction, what do we do? You put it over 1, right? Now what do we do? Keep, change, flip. I'm going to continue my steps over there on the right. But we do keep, change, flip, right? And so that was step 3. We're going to do keep, change, flip.
You might want to spread the x on the bottom. What? Your denominator for the
Oh,
first
square it, square it. Okay, got you. I didn't understand what you meant. Yeah, I heard you say spread it. I'm like, I don't know what that means. I was looking at this one and my brain was watching the x spread. I was like, I don't know what he wants me to do with the x. All right. So, okay. Now what we do is we cross reduce if we can. Now we can't. Okay. Nothing here reduces. This can't go into anything up here either. Because even though you guys might think, well, it can go into the x and the 2x, right? The problem is that this is a trinomial. When you have a trinomial, you can't reduce one of these without reducing it in all 3 of them at the same time. And that's why we usually just factor something out first, right? But nothing factors, so we can't reduce. All right, so at this point, we're done. We can't reduce, but the 4th step is to reduce usually.
Reduce is possible. Reduce.
And so my final answer will be this, x minus x cubed plus 2x squared over what? Cubed. Why is it cubed? Yeah, those two get put together.
Oh.
All right, so there's your 4 steps. It's just taking 2 things that we've already learned and putting them together. Adding 2 fractions together, even if they have an uncommon denominator, and then simplifying a complex fraction. That's all it is. It's a nice little skill builder problem. It's not really all that big of a deal, honestly, but it's not like a super important thing to know, but I like doing them because it develops a skill.
We should get like 4 questions for this one.
Yeah,
This is like a long.
it's a lengthy process. Let's see if we can make it go a little bit faster this time, though, because not that I know of. Not that I know of. This is a guided practice, so go ahead and write down number 2.
Oh, Mamma Mia.
Guided practice?
Yeah.
So, what's this lesson called?
It was 7.7, and I didn't title it. I just said the objective was simplifying complex fractions, part 2.
So it just
Oh,
brings 2
so-
lessons together.
Yeah, basically. All right. So let's go ahead and begin here. So I am going to ask you guys to walk me through this a tad. So my first step, Henry.
Yes.
What is the first step?
Well, you should work on the bottom first. So.
Good. That's enough. That's good. So now on the last one, I put combine the 2 fractions in the numerator, right? But this time my 2 fractions that need to be put together are down here. So the point is do the addition or subtraction wherever it's at. So yes, we need to do that. And I'm going to get people started on this a little bit. The top is going to be staying the same. Make sure your A's and 9s look different. It's kind of tempting to make them look the same. If you write like I do anyway. Okay, so I'm going to ask some questions and I'll let you guys do it. So, Kayla, what am I going to multiply this side by? Good. So you're going to multiply those 2 by 15 there, the top and bottom. And then Natalie, what are we going to multiply this side by?
5A.
Let's see. So we're going to multiply this side by 15, right?
No.
So that it has a 15 like that one. So Natalie, what does this side need that this side has?
A2.
Yeah, that's what we're going to put on there. So I'm going to let you guys simplify it, and I'm going to call on somebody to tell me what they got there. Do it. Take it all the way to the point where you have just one fraction, okay, on the bottom. So I'm just going to draw that. I should have one thing on the bottom and one thing on the top for me. Go ahead. Any questions?
I think I have the final answer.
Good. So if we multiply here, ooh, that's interesting. It moved. All right. So if we multiply 15 and 5, we get 75. If we multiply a squared and a squared, we get a to the fourth, and we're adding those. And our common denominator that they go over is 15a squared.
Why is 75 less than 25?
I don't know. I could definitely correct that. We don't want to be confusing. So there's that. All right. Oh, because I was underlining it. Made it look good too. Okay. So that's the end of step 1. Combine the two fractions into one. All right. Step 2. I'm going to ask Danielle. What's the next step, Danielle?
Then you do the dividing, right?
Change it to a division problem. So I'm going to ask, not Javier, he's not here, Heidi. How would I rewrite this as a division problem? I know I'm coming at you cold, but just try. We want to change this into a division problem.
Oh.
Huh? We're not going to do keep, change, flip yet. We want to do the thing we want to do the step right before that, where you write it as a division problem. So I'll set you up here. Do you know what comes first? All right. All right. You're right. Okay. Nathaniel, what comes next, sir?
You change flip.
Good. So it's going to be a over 9. This gets changed to multiplication. This gets flipped over.
Okay, can I tell us your final answer now?
No.
I've been dying this year. Oh, wait. No, I haven't because it's not the final answer. Never mind.
Adrian, what do we do now?
Which one?
You. Hernandez.
What?
That would be if we were adding or subtracting. Now we're multiplying. So I'm going to take a hand on this one. What do we do at this point, Nelson? You could multiply straight across, but I want to do something else.
Oh, I got you.
I would cross reduce.
So you take out
9 and
So-
15, you can take 3 out of both.
Here's what I want you guys to do. I want you guys to reduce the 9 and 15. So go ahead and do that real quick. I'm going to call on you and ask what you get there. Reduce the 15 over 9. What does that change to? So take a second and reduce those.
Ow.
I didn't reduce on my last problem because I couldn't, but this one does reduce. And you should always, so that fourth step was to reduce, right? All right, so Nelson, if I cross reduce, what goes into both 9 and 15? 3. So if I reduce the 9, I have what left? And here? 5. So now I've got 5 on the top and 3 on the bottom. And nothing else cross reduces because this A cannot reduce with this A because that A is being added to something. Anytime something's being added, you can't reduce it unless you reduce the partner it's with. And the way we usually deal with that is by factoring it out anyway. So we're done there. So now we're going to do what you said initially, which was multiply the tops together. So go ahead and write what you guys believe the final answer. Okay, go ahead, John. What is it?
5a cubed over 3a to the 4th plus 225.
Oh, so you actually distributed the 3?
Yeah.
You can do that. I'm going to not, but you can.
I know.
Well, the reason why I'm
I
not,
had my whole expectation. You just crushed my mind.
the reason I'm going to not is I'm pretty sure on my software they don't do it. And so on your test, I want you to get used to what you're going to see. But I could be wrong.
So step ahead.
I'm going to look and see what they do here. Let's see.
So is that the answer?
That is the answer. Let me see how the software writes the answer.
Yeah,
They
right
did.
now I did.
They distributed
Yeah.
it. So.
I was right this time.
All right, I'm going to get rid of the answer though. So yes, John. So if you guys are wondering what I was just talking about with John, he distributed this, and I've just seen a lot of problems in my software where they don't, but I guess on these they do.
So what is it distributed?
So yeah, we want to distribute. So if we actually distribute this through, it would look like this. Now, so we did a teacher example where I did most of the work. We did a guided practice where I let you guys walk me through it. Now I want you guys to try one completely on your own. We have another set. I'm not too sure why I made it in a. Oh, I know why, but we'll get there. All right, can I clear?
Yeah.
Okay, so here's yours. Okay.
Yeah, that is a me problem.
Alicia, what's the first step?
Oh, wait, I got it right?
Make the denominators the same. Okay? So, boom, boom, boom. After we get the denominators to match, John's not here today, I don't think. John's not here now. Gabriella, what do we do next? Gabby. What do we do next? After we get a common denominator. Okay. Okay, next. David's not here. Augustine. ¿Qué más?
Oh, you joke? I thought you were looking at me. I was like, you're wrong.
Okay. So we're basically going to put the fractions together, right?
What'd you do?
And I don't think there's any like terms that can go together, though. But we will put the two together as one fraction at least. Okay, next one. Kendall's not with us. Joanne, what's next? Has a division problem, right?
Why'd you do this?
Okay. Next we have Alexis. Shh. Gross. Alexis, what do we do here? Keep. Change. Flip. What's the next thing we check for Kenny? Nope, Kenny's checked out. All right. What do you know what we do next? Okay. Why don't you unplug your ears? You might get something from me. It's worth a try. Eric, what do you think? What do we do next after keep, change, flip? Okay. Let me take a hand. So let me talk to this gal. We're just going to multiply straight across. But first, before we multiply, what you're supposed to check for is can it reduce, right? But nothing reduces. This is a 2 and an A, and that's not going to reduce the 9 here. And in the binomial, you can't reduce a binomial unless both of these things have a common factor that you can take out or factor it in some way. So we're done. So you just multiply straight across. And what do we get, Danielle, if we multiply straight across 9 here and 2 here?
98 squared plus 5.
It's 54.
Yeah.
Over? Over?
Over 4.
4, 8. Notice, you guys, that when we do this, you distribute the 9 to both numbers over there, okay?
Can we all agree to not use 9 and 8 in the same problem? My brain just flipped everything.
I wish I could say yes to that, but I'm going to let the computer generate questions for us. Well, I think kind of pushing my luck here, but let's see what's next. I'm curious.
Can we stay on this subject? I think we're kind of struggling.
Okay, let's do one more problem. One more. This is not a student practice. It's going to be like a us practice, a guided practice. Ready? So go ahead and write it down, please. Let's begin here. So, step 1. Chris Jones, what do we need to do first?
Make both sides equal or whatever.
Okay, kind of. I think you're on the right track, yeah?
You should factor out the 5x.
That's pretty fancy. That's right. But the answer, what I'm looking for is get a common denominator.
Oh, first step.
Okay, so, and Henry's correct. For this one now, we're not dealing with just a single number down there, right? We have an actual binomial. And so anytime you have more than a single number down there, you've got to factor first. So, well, I want to give people a chance to get it. But this one down here, the x minus 3, does not factor. There's nothing you can do with that, okay? But this one over here, there is something we can do with it. We could take out a GCF. Okay? So I'm going to ask Adrian Canizales. Canizales, can you tell us?
Canizales, can you tell us?
No? Can you tell us what goes in the blanks here?
First one's a 5, right?
I agree.
X.
I agree.
3.
I agree. Okay. So now that we factored it, now we can start matching them, right? So Paris. Paris. What do I need to multiply on this side so it looks more like that one? Cinco. Bueno. Jonathan, what do I need to multiply over here so that this one matches this one? Nothing. It's good, right? All right.
You tried playing a mind game on me.
I did.
We're going to answer the next step?
Sure, go ahead. What is the next step?
You are going to combine my terms now.
We are. These are going to go together. So this is 5, right? I'm just going to cross out, put a 5 there if you guys are okay with that. And then 5 take away 16 will be what?
Negative 11.
Uh-oh. Got a little carried away. Negative 11 over that common denominator, right?
And then.
No. No, young man.
Why? You have to suppress my brain.
All right. Micah.
That messed up.
Micah, what's next?
Change it to division.
Beautiful. Beautiful. Top divided by bottom.
Well, you might put it over 1, please.
I will do that.
And then you keep change flip.
Stop.
You just stole so much answer.
He did. It was Hannah's too.
Yeah, take points off.
So we're going to do keep, change, flip. So it's going to be keep. Change. Flip. Hannah, can I reduce this number and this number? Huh? No. Can I reduce this with anything up here? No, it's just 1, right? So we're good. So what do you do after the reducing step? La fin de ne. Huh? What? Oh, okay. Yeah, that's what I thought she said. But when you saw me getting closer, you got intimidated, huh? You were like, I gotta answer, he'll hurt me, right?
No, she thought that.
All right, so we're gonna multiply straight across. It's going to be negative 11 over, all right, I'm going to do the 25 and 5 first. That's 125.
I'm gonna distribute that in.
And if John's right,
Can I say it? Can I say it?
I guess so, dude.
It's 125x minus 375.
Okay, so negative 11. I'm going this way now in case you guys missed that.
Wait, that's all that goes with it?
375?
Yep.
Okay.
What the hell?
You wanna fact check me?
No. I believe you.
Oh, you're dead.
All right, we're done.
We're done. Like we're done.
Please go over. Please go. Please go over.
Oh, we got homework.
What?
Okay.
Mr. Bailey, since we're done so early.
I see you, Heidi.